Okay, we're using our join the dots method to graph some functions or to get a picture of some basic functions. And the next one we're going to look at is g of x equals x cubed. So we pick a few values of x, plug in those values of x and see what points we get in the graph. We draw those points, we join the dots, and we assume that we have most of the important trends of the graph on our picture. When x is minus 3 cubed is going to be minus 27. When x is minus 2 cubed is minus 8. When x is minus 1 cubed is minus 1, 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, and 3 cubed is 27. So the picture of our graph here, the picture we get, 0 here, 1, 2, 3, minus 1, minus 2, minus 3, and we ought to let this y-axis run from, say, minus 30 to 30. And we'll just have increments of 10. And our first point is negative 3, negative 27. So it's down about here. Next one is negative 2, negative 8. So it's here. Negative 1 is probably way up here. And 0, 0 is here. 1, 1, 2, 8, and 3 with 27, which is way up there. We get this nice graph. It's leveling off as it approaches the origin. It stays level for a bit and then it speeds up as it heads away from the origin again. We assume for the moment it keeps increasing in this direction and decreasing in this direction, and that is in fact true, and we're going to add this picture to our catalogue of graphs to give us a picture of the graph of this function for future reference. Let's see what happens with the square root of x. When x is 0, square root of x is 0. 1, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. You can see a pattern here, I'm sure. Square root of 25 is 5, square root of 36 is 6. And let's see what points we have in our graph. Of course, the domain of this function is just x values which are greater than or equal to 0. So we really just need the right hand of the plane, or the right half of the plane, to graph this function. Now the x values should run from 0 to 40, say. And the y values here need only go as far as 10, let's say. 2, 4, 6, 8, and 10. We have the point 0, 0s on the graph. 1, 1 is about here. 4, 2, about here. 9, 3 is about here. 16, 4 is about here. 25, 5 about here. 36, 6 is about here. So we have that this graph is increasing as we go to the right. May not be exactly correct, but it's leveling off. It's slowing down, the y value increase is slowing down as we move to the right. And this is the basic shape of the graph y equals the square root of x, and we'll also add that to our catalogue of graphs. There's an interesting feature on the graph of f of x equals 1 over x. Of course, we're looking at the graph of y equals 1 over x. And as you get closer and closer to x equals 0, the y values on this graph head off towards plus or minus infinity. So let's see what happens here for values larger in absolute value than 1. If x is minus 100, 1 over x is minus 1 over 100. So a negative value of x is going to give you a negative value for f of x here. If x is negative 10, then f of x is negative 1 over 10. X negative 1, negative 1 over x is negative 1. If x is 0, our function is not defined. So 0 is not in the domain of this function, so we don't have a point on this graph where x is 0. When x is 1, 1 over x is 1. When x is 10, 1 over x is 1 over 10. When x is 100, 1 over x is 1 over 100. Now you can see these values are very, very small in absolute value. So let's draw a picture of what we've got so far. Here's our x-axis, here's our y-axis. And now we have our x's ranging from minus 100 to plus 100. And we had when x is minus 100, well, actually we need to grade our y values, but we're going to use this right-hand side as well, so actually our y values are going to go all the way up to 1000. So this point, negative 100, negative 1 over 100 is very, 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 very close to the x-axis here. And it's beneath the x-axis. Negative 10, negative 1 over 10. Well, negative 1 over 10 is a little further down, but on this scale probably doesn't show up as being much further down. And negative 1, well, it's probably about here. In fact, that's probably even too much. Then we have 1, 1. 10, 1 over 10, and 100, 1 over 100. So it's very, very close to the x-axis there. So far, our picture, our join the dots picture looks like this. This thing is getting very close to the x-axis as we move away from the y-axis. And let's see what happens now for very small values of x. Well, when x is negative 1 over 10, 1 over x is negative 10. And when x is smaller still, negative 1 over 100, 1 over x is negative 100. When x is very, 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 very small, x negative 1 over 1000, 1 over x is even bigger still, it's negative 1000. Bigger in absolute value. 0 is not in the domain of this function, so 1 over 0 is not defined. When x is 1 over 1000, 1 over x is 1000, that's huge. When x is 1 over 100, 1 over x is 100, and when x is 1 over 10, 1 over x is 10. Okay, so for points very, very close to the origin, say x equals 1 over 10, we get the point 10 here x 1 over 10, 10 is on the graph. X 1 over 10, y equals 10 is on the graph. X 1 over 100, which is smaller, y equals 100 is on the graph. Actually, that's probably a little off. Should be about there. And these are getting harder to draw because the values of x are very, 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 very close to the origin, and the scale is pretty huge here. So when x is 1 over 1000, this point is very, very close to the y-axis. The y value is way, way up there at 1000. So as x draws closer to the y-axis, it gets steeper and steeper and steeper, and this graph goes away off to infinity. And the same thing happens. We have symmetric points. This graph is symmetric in the origin if you replace y by negative y and x by negative x, you get the same equation here. So the graph on the other side is the symmetric reflection of this in the origin, and it looks like that. The graph of y equals 1 over x looks something like that. As the x values get closer and closer to 0, the graph heads off towards plus infinity on this side, negative infinity on this side. And as we get further and further from the origin, the y values get closer and closer to 0. We'll also add this graph to our catalogue. When we refer to it, we'll sketch something like this for y equals 1 over x, and we'll talk about shifts in the graph and so on, which will help us graph rational functions.